Hello, welcome to our perceptual learning activity. We're going to look at whether the formulas for the standard error and z-test were applied correctly. You may have heard the term plug and chug, and we're going to look at were the formulas plugged correctly before they were used to chug out the answer. To help us decide this, we're going to be given some basic information regarding the null hypothesis distribution. We'll be told that for that normal distribution, what is its mean and what is its standard deviation. So in this example, the mean is 23, standard deviation is 14. And then for the sample, we'll be told its size, 25, and the mean, 18. So then we get to the challenge of this particular activity. Are we putting the correct information into our formula? So for the standard error, it's equal to the standard deviation divided by the square root of the sample size. So we check to see, do we have the standard deviation? Yes, it's 14. And do we have the correct sample size? Yes, it's 25. So that gives us a standard error of 2.8. For the z-test, it is calculated as the sample mean minus the population mean divided by the standard error. So our sample mean should be 18, that's correct, and the population mean should be 23, that's correct, and it's divided by the standard error. So this scenario is correct. We can go ahead and click on it. For our next scenario, we're going to take a look again at our null hypothesis distribution. This one has a mean of 21 and a standard deviation of 16. Sample size is 20 and the sample mean is 17. So in calculating the standard error, we take the standard deviation of 16 divided by the square root of sample size. Sample size is 20 and this used 21. So that's incorrect. We send the scenario back for revision. So there's 10 such trials. Then we look at this next card, our hypothesis distribution, mean of 22, standard deviation of 23, sample size of 17, sample mean of 39. So standard error, 23, yeah, that's the standard deviation. Divided by square root of 17, yeah, that's the sample size. That gives us 5.6. Then the z-test, sample mean of 39, yep. Population mean according to the null hypothesis, 22. Divided by standard error, all looks good. We click on the card to keep it. Now on to the fourth example here. We're given a null hypothesis distribution with a mean of 20, standard deviation of 19, a size for our sample of 22, and a sample mean of 31. Look at the standard error. It should be standard deviation divided by square root of sample size, and standard deviation is 19, and that's not what was plugged here. So we send the scenario back for revision. So in doing this PLA, it's just testing, are you comfortable and confident with how to put the information into these two formulas, the standard error and the z-test. The z-test is really important. It's going to tell us the number of standard errors between the sample mean and the null hypothesis mean. The smaller the z-test, the more accurate the null hypothesis distribution is in predicting where the sample mean should end up. If we have a small z-test value that's close to 0, either plus or minus, if it's close to 0, that's telling us that the null hypothesis distribution did a great job. If the z-test is really large, either positive or negative, then that's telling us that using the null hypothesis distribution to make a prediction did not work out so well. A prediction was made and it was off the mark from where the sample mean actually appeared. So this helps you to better understand how we calculate this important information, and you can also see what it looks like in terms of the null hypothesis distribution and the sample mean. Wish you the best as you do the activity.